Today we're going to talk about a new way to calculate slope, and we'll base it on what we learned last lesson. So if you look at this question, find the slope of the line connecting the points A, 1, 2, and B, 4, 7. So we can actually take those and plot it right on this line. So there's A and there's B, and then the line connecting those. Now that line goes on forever, or just the line segment in between, doesn't matter. So last time we talked and discovered that we can find the slope by doing the rise over the run, going from the point from the left to the right. This is a positive correlation, so it's a positive slope. It's going to be going up. So let's go and count. So we can count our way up, our rise. 1, 2, 3, 4. Sorry, 1, 2, 3, 4, 5. So we rise 5 steps, and we run 1, 2, 3, 3 steps, and so the slope of this is 5/3. So that's a great strategy to calculate the slope, especially if we have the graph. But what today's lesson is all about is how can we calculate the slope without having to graph it? It takes a lot of time to get this out, put the points on, and graph it. So we'd like to come up with a way to calculate the slope without graphing. But let's talk about rise and overrun again. Let's talk about slope. The rise is describing this change right here. So we can think of that as the change in the y values. You see the y value here starts at 2 and then it goes up to 7. So this rise describes the change in the y values. And therefore the run talks about the change in the x values. See, it starts at 1 and it goes all the way over, the x values change over to 4. And so another way of imagining the slope is this, with this delta y over delta x. Now delta is a Greek letter, and in math it means change. And so this is a fancy way of saying the change in y over the change in x. Delta y over delta x. Just a fancy way to describe rise and run. But this concept of calculating the change in y and the change in x is going to lead to a formula that's going to be very handy. So let's really dive into where this 5 comes from. So it is the rise, but to calculate it, look at the y values. The y value starts at a 2 and goes to a 7. So the change from a 2 to a 7, well, you get that by doing 7 minus 2. Remember, if you're talking about the difference, you start about where you are now versus where you began. So if I'm at a 7 now and I began at a 2, the change is a 5. So we can calculate that by saying 7 minus 2. That the top number, the rise, comes from doing 7 minus 2. And the run behaves the same way. We're at a 4 right now. Where did we begin? We began at a 1. So the change from 4 to 1, 4 minus 1, gets us our run. So of course 7 minus 2 is 5. 4 minus 1 is 3. And we get that same slope that we calculated over here. But we can get these numbers right from the points. So we can see the change in y and the change in x without actually visually seeing the rise and the run. We know the rise comes from the change in these y values and the change in the x values. So this is where the idea of a formula can come from. So what we're going to do is we're going to call these numbers, we're going to give them labels. So the first one, the first point, we're going to call it x1 and x2. Now this is just a little notation one. It's saying the x coordinate in the first point and the y coordinate in the first point. And then this one we're going to call x2 and y2. Notice these aren't squares, these aren't exponents, these are little 2's. That's why they're called subscripts. They're down at the bottom. So we just say x2 and y2, and it's just a way of labeling the second point. So this becomes the x in the second point, and this becomes the y in the second point. So this rise is the change in y. So it comes from the second y value minus the first y value. So we can say y2 minus y1. And then the bottom, the run, comes from the change in the x's. And so it's where you are now, in this case the 4, minus where we began, the 1. So that's x2 minus x1. And the result is this thing which we call the slope formula. And the slope formula is this and this one and Pythagorean theorem are the most important formulas you're going to learn in grade 9. So I'm going to put some stars around this. That's how important this formula is. Okay, so with Pythagorean theorem, the slope formula, these two things are the most important formulas from grade 9. Okay, and we are going to use the slope formula for the next 2 units, at least 3 units even. Okay, and then you'll be using it in grade 10, 11, 12. My grade 12 still use the slope formula when they're doing calculus. That's how important this is. So because it's so important, I'm going to really impress on you how important it is for you to practice and get used to this slope formula. So let's do a couple examples. So we're going to use the slope formula to calculate the slope of the line between the points instead of graphing it. Okay, so here's the first example, A12 and B10(8). So as you do these questions, and I might even tell you to pause the video and grab a piece of paper, because I want you to mimic exactly how I answered this question, okay? And following this pattern, because you're going to be doing this so often, I know the best way to do these questions. I don't want you to try and come up with your own formula or your own process. I want you to follow this and repeat it and repeat it and repeat it. And that's when I know you'll be good at it. So what's the process? I'm going to ask that you write down the formula every single time you do it. Okay? For all the practice you're going to do today, for any questions you hand in to me, I'd like you to write down the formula. This is my way of helping you memorize this. Okay? Even though we understand where it comes from, it's going to be very important to write it down. So we're going to write that down. Okay? This part you don't necessarily have to write down. You don't have to write down x1, y1, and x2, y2. I'm going to write it down just to help us. Okay? So this part you don't have to write down, but you do have to write this down. Okay. So first we're going to do the rise, which is the change in y, the delta y. And we see we're at 8 minus 2. So if we're calculating this, the y2 is 8 and the y1 is 2, and it's 8 minus 2. And then the x2 is 10, subtract the x1, which is 1. And now it's just a matter of doing some simple math here. 8 minus 2 is 6. 10 minus 1 is 9. So the slope is 6 over 9, but if you remember, we like to have the slope in lowest form, and this is a fraction that can be reduced. We can divide the top and the bottom by 3. So 6 divided by 3 is 2, and 9 divided by 3 is 3. And so the slope of this one is 2 over 3. So if we were to graph this, we could rise 2, run 3, rise 6, run 9. We would get to all the points on that line. Okay? So again, I'm going to stress this. Write the equation down. Substitute in the numbers. Do your math. Simplify if you need to. Work down. Don't work across. Work down. Okay? So I'm going to expect that I see this process every time we do a question. Let's do a second one. First step, write the equation. y2 minus y1 over x2 minus x1. Here, I'm going to highlight which one is x1 and x2, and x1, y1, x2, x2, y2, but you don't have to write that part. You just got to write this. Okay, let's fill in the blanks. y2 minus y1. All right, so that's 0 minus 2. 0 minus 2. Now be careful when we do this next one. The x2 is 4, so we're at 4, and we're subtracting where we began, except this time we began at negative 3. So think about that. If your x is at 4, which is way over here, and you started at negative 3, you're quite a ways away. You're actually 7 spots away. And why is that? Because 4 minus 3, when you're subtracting negatives, remember you're subtracting cold, you're actually getting warmer. So 4 minus 3 means 4 plus 3. Now the top is easy, 0, subtract 2 gets us into the negatives, and we get negative 2. but the bottom is the one that some people get slipped up with. So 4 minus 3 is 7. You are 7 spots away between these x's. And then we get the formula, the slope formula then is negative 2 over 7. And this graph then must be going down. So it starts at negative 3, 2, and it goes down to 4, 0. Okay? All right, let's do another one. C. We've got our points. What's the first thing we do? That's right, write down the formula. Okay, let's do our y2 minus y1. X, or y2 minus y1. So 4 minus 1, that part we've got. And then here we've got some negatives, so we're going to be very careful. X2 is negative 3. And we are going to subtract, what are we subtracting? A negative 4. So minus 3 minus 4. Well, the top, first let's do the top. Top is easy. It's 3. The bottom, however, is minus 3, subtract negative 4. So subtracting cold makes you warmer. We started at a negative 3, and we subtracted cold, so we got warmer, and we're at 1 now. Negative 3 plus 1. And even just think about this. If you're at negative 4 on the graph, and you need to get to negative 3, how do you get there? You go up 1. And there you are, up 1. Now, 3 over 1, this we can leave as 3 over 1, that's fine. But most often we'll just say 3 over 1 is 3. 3 over 1 is the fraction that represents just 3. But we'll probably just write down this 3. Okay? I didn't write the x2, y1, and so forth up there, but you could. All right, so this is the process. How important is this process? Well, we're going to do 2 more of these questions. All right, just give me a second here, sorry. All right, you kind of had a sneak peek at the answers, but that's okay. All right, y2 minus y1. Again, regardless whether this is the 3rd time, the 4th time, the 20th time, we're going to write down the formula. y2 minus y1 over x2 minus x1. So let's do the y2 minus y1. So that's going to be a 1 minus 1. And the x2 minus x1 is going to be 4 minus 1. Well, that's interesting. 1 minus 1 is 0, and 4 minus 1 is 3. Well, what's 0 divided by 3? Well, you can check that out. You can punch it in your calculator. 0 over 3, 0 divided by 3 is 0. Okay, so what does the slope of 0 look like? Well, if you think back to our first few days of investigating slopes, 0 represented the horizontal line. That's a slope. Remember, you do 0 skiing. Okay, so that means there is a slope, it's just 0. We can check this by checking out the graph. So if we did this little graph, a really rough little graph here, and I'm going to put in the points. I'm going to put in 1, 1 and 4, 1. Those points are on there, and look, if you connect them, you get that horizontal line. You get 0. Okay? All right, let's do another one. What's the first thing we do? Write the equation down. y2 minus y1 over x2 minus x1. So we change in y. So this is 3 minus 5. Oh, interesting. 3 minus 5, that's going to get me a negative. And 2 minus 2. So 3 minus 5 and 2 minus 2. Well, 3 minus 5, that's going to be negative 2. But the bottom is really interesting. 2 minus 2. Now we get negative 2 over 0. A lot of people tell me that this is 0. Well, it can't be. When 0 is on the top, you get an answer of 0. But what happens when 0 is on the bottom? That is saying you're dividing by 0. Now, I encourage you to grab your calculator right now and try it. Try negative 2 or any number divided by 0. And your calculator is going to say error. That's because you cannot divide by 0. Okay, it's impossible to divide by 0. Okay, the way I remember it is if you've got 0 and you want to divide it by 3, that means how many times does 3 go into 0? Well, it happens 0 times. But this doesn't make any sense. How many times does nothing go into something? What? That's impossible. So you cannot divide by 0. So we say that's undefined. Remember that? Remember those undefined or doesn't exist or no slope. So these ones will be the ones that tell you the no slopes. And if you think back, those represented vertical lines. So here's another graph. Here are those 2 points right on there. And then if we graph the line, we get that horizontal line, right? 2, 5, 2, 3, 2, sorry, 2 5's up there, 2 3's right there. There's a horizontal line. Doesn't matter how much the rise is, it's always going to be no slope. Okay? So here's going to be my challenge. I cannot stress enough how important the practice is with this. And here are some questions. So I purposely hidden the answers right now. So you can pause the video and try a couple of these questions by writing the equation down, substituting the numbers, working down, using this form that I've stressed here each time. And then after you are done practicing these, you can replay the videos and I'll show you. So pause right now and come back in a second. All right, hopefully you've tried these and now you can check your answers. And there are the answers. Okay? More practice we can have there. So I'm going to ask you to submit a couple of these answers. And I'm mostly doing it because I want to see that you're using the proper form. You can go back and talk to any of my grade 9s from before and how much I stress this form. And I would have them up on the whiteboards all the time showing me this form. And a few times people would ignore me and they would get wrong answers. And it was really great to see that up on the board where people were ignoring my process and getting the wrong answers. And the people who followed my process got the right answers. And it's not just me. Every math teacher in the world really wants this process because everyone knows how important the slope formula is. Okay? So when you are asked to demonstrate this for me, please, please, please practice that process and make me proud. Good luck.